Okay. Chapter 10 in Mythical Man-Month, the documentary hypothesis. That first paragraph is one that I've quoted in a number of expert reports, particularly regarding failed projects. We tend to, I mean, what are some of the big problems with documentation on a project? The documentation about the project, documentation about the software, and so on, yeah.
A lot of it's boring.
Yes, a lot of it is very boring. It's boring to read and it's boring to create, isn't it? What are some other problems?
Sometimes the person that writes it understands it in a different way than the way that you wrote it. So he might be putting in things that he understands, but other people won't understand.
That's a very important observation. The language is, I got contacted by a lawyer about a new patent case. And he asked me to look at a particular claim in this patent. And it talked about gathering information without input from the client. And I wrote him back and said, well, there's a problem here because I don't know if that means that the client didn't give you the firm executing the patent the information, or they didn't give the provider the information. So it's interesting how relatively small things can cause confusion. What are some other problems with documentation? Yes?
It doesn't update itself.
Oh yes, it doesn't update itself. It's always out of date. I mean, the classic thing is the only real effective documentation is the source code itself, and sometimes that's not always true because you have dead or near dead code in it. Other things? Yeah?
It either never gets created or never gets recorded.
Yep, never gets created or recorded. The point here, the act of writing stuff down, particularly in doing requirements, which is what we're talking about, often requires hundreds of mini decisions. How many of you in your projects right now have found out that as you've met in a group and started to talk about what you're doing, that you're having to make lots and lots of additional decisions? What are some of the issues that you've run across already just in the 2 weeks you've been doing this? Anyone? How many of you have a clear, uniform idea among your team members as to what you're trying to build? Yeah. If it's a team of one, maybe. Though speaking from personal experience, there are times like, well, no, that's actually not what I want to build. I like the third point here. The manager will be continually amazed that policies he took for common knowledge are totally unknown by the members of the team. How many of you have suffered that gap where you're working, those of you who've worked as interns or regular jobs, where you think you're doing something and the manager thinks you're doing something somewhat different, or in case it's totally different? Anyone had that experience? Yes.
Yeah, no, I had that experience. I'm pretty sure when I left, my manager saw a whole bunch of stuff that I was doing. He didn't even know I was doing. So.
Yep. And so the point here is that you want to write stuff down, you want to make sure everyone reads it, and you want to make sure everyone understands it the same way. That's part of what you're going to be doing with your requirements document. Now, you're on a very short time frame, so you don't have a lot of time to mess around. And one of the feedbacks I get at the end of every semester when I ask for lessons learned is that we didn't talk as much as we needed to with each other. You know, we got 3 weeks into this and found that 2 different groups or 2 different programmers had significantly different understandings of what they were supposed to be doing. This is why you have a wiki. This is why you're being forced to create all these various documents and put them there, and why, if you're doing it right, you will be revising them on a regular basis. All your documents should be subject to revision. Any other questions or observations about this? Yes?
So, the book said that part of the reason that documentation is so hard is not because teachers don't teach the importance of it, is that they don't show how to do it.
Well, there's that.
And
Yes.
I feel that. It's like, I don't really know how to document my code well. I'm like making it up right now. So, where do I go to find out what good documentation methods are?
That's almost a whole other lecture, which is my way of sort of ducking the issue right now. The one thing that you may consider doing, though again you're on a very short time frame, I've mentioned the startup pages. I was chief software architect. I was the one hiring all the engineers. And I actually wrote up a standards and guidelines document saying, here is how you write your code, here's the naming conventions, here's how you'll comment, here's how it'll be formatted. Since I had a lot of bright independent developers, they didn't always follow them. And I would go through and basically reformat and comment other people's code. Because it's a communication issue. It's hard enough to pick up a piece of code you didn't write and figure out, truly understand what's going on. If you have different naming conventions. Frankly, if you have different places you put the braces, it can be hard. You can overlook it. You can think, oh yeah, that block is closed. And no, actually it turns out that block is not closed. So this is a perennial issue. It's like, well, code should be self-documenting. It should just be clear. This is why you want to tend towards shorter routines, shorter methods, things that are small enough to be readily intelligible. But what you're really doing when it happens is you're pushing the interface and connections out to all the various routines that are having to call each other. And that sometimes is even less documented. This is sort of the deep interface that I think I've already mentioned here on APIs. There's two types of APIs. There's the API that says, here's the method function called whatever name and the parameters and what the parameters are, and this is how you use it. Deep API says, you have to call this, and then you have to call this, and if the result is this, and you have to call one of these two. That's the stuff you go on Stack Overflow to look up. It's like I can look up all the individual functions, but if I'm going, if I want to know how to put them together, that's another level of documentation. Any more questions or comments here? Chapter 8 and Accelerate, and I think if I didn't have this on the reading list, go read it. It's a short chapter. This is all good advice for you. Work in small batches. In my analysis of failed or failing projects, inevitably there's a big bang approach to release. It's like we're going to work on this for a year and a half, and then we're going to see if it all works together. That seldom works correctly. This is the whole impetus behind the Extreme Programming Manifesto. It's do it in small batches, try to have something running at all times, and make sure everyone understands the end-to-end stuff. Again, one of the problems I've mentioned with Agile-like approaches is you can get stuck on a local maximum. This is classic. Here's a 2D plane, and you start out here, and you're making decisions, and you find this hilltop here, and your decisions lead you to the top of the hilltop. You think, this is great, this is the optimal solution. Whereas you have a hilltop like this over here that you never see. Because you haven't examined the whole problem sufficiently. So this is the problem with Agile. Sometimes you get to here, and you don't want to start making things worse, though you actually have to make them worse before you can find a taller hill. So you've got this trade-off. Now, of course, the problem with a pure waterfall, whatever, is the classic analysis paralysis. You're researching stuff for a long time. And you never actually commit anything to code because you think, wait, there may be something better. I think I've told you, I mentioned when as an undergrad here at BYU, my very first job was with a computer-assisted translation research project here at BYU, headed by Dr. Olden Lytle, where they would take an English text. This was being funded. The intent was to help the church with translating materials. You'd have an English text. You go through and analyze it with human-computer interaction. So the computer did not have to resolve all the difficult references. Classic case. How many different ways can you interpret the phrase, the man painted the girl on the horse? Okay. Did he make a painting of a girl on a horse? Did he paint a girl on the side of the horse? Did he slather paint so she was stuck to the horse? Stuff like that is very hard for computers to analyze correctly. So you have a human doing that, it would go to an independent format, and then it would go straight out to multiple languages. This was based on a grammar theory called junction grammar Dr. Lyle had invented. Brilliant individual, but here was a problem that I experienced in the 4 years I worked on the project, which is every time we'd sort of get close to what we thought was a functioning system, Dr. Lyle would come back and say, wait, I've changed junction grammar. I've got a new model here, some new things, and we'd have to go back and redo stuff. And we literally never, in the 4 years I was there, got it all the way through because he kept changing the underlying grammar. Adapt quickly and work around barriers that arise, be open to experimenting. That's a good practice. I don't know how much time you're going to have, but here's what you want to do, and this is going to be, I think, in next week's readings, unless it was in 2 weeks ago. Don't defer the difficult. Use the risks and issues thing on your status reports to identify your hardest problems. Figure those out now, because you may want to cut out the features that are causing those hard problems. You learn nothing else from this class. Learn that the only way you can gain scheduled time is to drop features. Nights and weekends won't do it. Miracle coding sessions won't do it. You have to drop features. And so what you want to do is understand as fast as possible what features you can actually achieve and which ones are just going to take so much time it's not going to be worth it within the time frame you have. And you're all on the clock. You can't say, oh yeah, we'll finish this next semester. Anyway, questions, comments, feedback? I get suspicious when I don't see hands. Yeah.
How does software architecture, right, and design patterns, how does that flow into deferring the difficult, right? Because in some sense, if you make good architectural decisions, you actually are intentionally deferring the difficult in some sense.
Well, hopefully what you're doing at Pages, and the advantage I had with Pages is we were trying to raise funds. So I had a lot of time to work on the architecture. Without actually writing code. Well, I was writing code, it was mostly prototype code to show to investors. But I had a lot of time to think about this and work through the problems. Now, Pages, and I should do a presentation on Pages at some point here. The idea was Pages was a design-oriented desktop publishing system. Whatever you did would be well designed. And you could change from one design model to another, and it would reformat and reflow everything, and it would still be well designed. And the founders of the company were a world-famous typographer, Mike Parker, find him in Wikipedia, and Vic Spindler, who was a successful graphic designer, had worked at CBS for a number of years, and so on. And I went to Vic after we got started, and he had a few sample design models, and they were fairly safe and fairly conservative. And I went to Vic and I said, I need for you to write out or design out a design model that pushes the boundaries of what you want to do. That's sort of the most extreme that we're likely to do. So we came up with one called April Greiman. He called April after April Greiman, who was a graphic designer. And it had circular headlines and had text flowing. I mean, it was a nightmare. And it was the best thing that Vic did because I had to come up with an architecture that would not only do the safe conservative design ones, but would also work for April. And every time I thought I had a solution, I'd go and say, okay, how will this work under April? It's like, oh crap. But that's the advantage of a longer thing, is you want to make sure your architecture has a circle of all possible solutions that you're willing to take. And that basically kept pushing out the difficult to me. It's what helped me to see it. So what you want to do with difficult stuff is you want to identify as soon as possible and either cut it out completely or make sure you're drawing a box that encompasses it. Yeah?
So going back to your story with this professor who had that language identifying stuff, it seems like there was like a fundamental disconnect between what you guys were trying to accomplish as developers and what he was trying to accomplish as an academic. And so like, I don't know if it's specific this scenario, but how would you like reconcile that difference of what you want to do as like someone who's working under someone else?
Knowing what I know now, if someone called me back, 45 years ago, a long time, 74 is when I started there, to advise it, I would take Dr. Lytle aside and say, let us get all the way through, on one version of junction grammar, so we can do end-to-end work and really see how well it's working. And then, if you want to make changes to the underlying linguistic model, let's do incremental changes and see how we can implement. So this is going back to the previous slide, work in small batches. Get it working so it's working end to end, and then let's do some successive refinement to make sure that we're not breaking anything. Or if we're breaking anything, we know and we have a working system we can fall back on. Yes?
I think that his question raises another good question, which is how, say you're the developer, and then you've got somebody who's giving you the work, who is in charge. How do, if you see a problem with the solution, with the architecture, how it's being programmed, or something that you want to address, what's the best way to do that to somebody who's in charge of you?
This is really hard. There's a number of versions of this problem. One of the biggest is technical debt, which is where they say we have to ship third quarter this year. And you say, we don't have time to get it done. Well, what can you get done? Well, we can get this done. We can do some quick and dirty solutions. We can get it functioning this, but you're going to need to give us time to go back and fix things once we get it to ship. And you ship, and they say, okay, here's the new list of features we want. It's like, no, wait, we have technical debt. And they say, no, we're going to push ahead. This is how a lot of the software industry operates. So if your question is, what can we do? It's like, well, you can do the work, you can change jobs. You may or may not, remember my dictum, the only way to change an organization is to go in every day prepared to be fired. And if you're not prepared to be fired, then you're going to have to live with what's coming down from above. I mean, quite literally, if you're not prepared to be fired or to change jobs, you're going to find yourself living with situations that you're unhappy about. That's sort of the reality of software development. Let me tell you now, let me warn you now. You're going to have jobs that you really like, and you're going to have jobs that you really, really don't like. Shortest I've ever stayed as a job was 6 months. Love the job, lifetime goal. I was working on the space shuttle flight simulators at the Johnson Space Center at NASA. I mean, I've been following space programs since age 8. I was meeting astronauts. I was contributing to the space program. And the management at Singer Link was awful. And I wasn't able to do much because I had to have access. I basically had to have the simulators to myself in order to do any debugging or testing. There was no separate test environment. So I typically got it from 1 to 3 a.m. on Wednesday nights. And I'd be sitting there and kick whoever had it. It was the simulator scheduled 24/7 because they're training all the astronauts. First shuttle flight hadn't gone up yet. They're training the astronauts. You had 3 different contractors. You had Ford, IBM, and Singer Link all working on the simulator. It was 2 mainframes and half a dozen mini computers. My system was on one of the mini computers, sat between the mainframes and the 2 space shuttle simulators, and I had to have control of the simulators in order to do any testing, to try and reproduce bugs or test out fixes. And so I'd do that, come into work the next day, and would have about a day's worth of work that I could do, and then had to sit and twiddle my thumbs until the following Wednesday. And after 6 months, I was ready to slash my wrists. I mean, it was boring beyond words. And found a great job next door at the Lunar Planetary Institute, so I went over there. But this is a real issue. This is a real challenge. It's not, I'm not going to trivialize it. It's something you're going to face. in your jobs. And the question becomes, okay, how much do I like my paycheck and what opportunities do I have somewhere else? Fortunately, you live, or you're all going into an industry where demand outstrips supply. Unfortunately, you're going into an industry where companies are really bad, generally speaking, at hiring IT people. They look for the wrong thing, they screen in the wrong ways, and you get people who, you know, immensely talented and qualified people have a hard time getting a job because they can't quite make it past the HR department. Which also brings up, I mean, it's a time-honored truism across business that the best way to get a good job is who you know. It's contacts, it's personal relationships, and so on. You want to network a lot. You know, don't depend on Monster or LinkedIn or whatever the current job sites du jour are. Build contacts, schmooze, go to conferences, talk to people. Some of the best jobs I ever got came out of the blue because of people I happen to know. Any other questions before we move on here? How to retain talent with goal alignment. I think I've mentioned this some already. I'm trying to think of why I threw this into this group, but we'll talk about it. We talked with some of the earlier stuff about the level of turnover, density effect, the fact that good people leave. It's hard to hold on to good people. Mike, how hard is it to hold on to good people?
Oh, it's almost impossible these days. And it's not just development. People, especially in the valley here, companies are poaching employees from you left and right. They find out and hear, and so very difficult.
Yeah.
Nearly impossible.
Yeah, it's very hard. But that should all encourage you who are looking for jobs. We were having this problem, I mentioned this at Pages. I hired all these bright developers, and then it was like herding cats. And I was not qualified to do it. One of the engineers, Rick Gessner, had some great training in conflict resolution that helped. And then we did an off-site where just us engineers went off close to the beach in a hotel, sat outside in the San Diego weather. It was great. Large flipboard, and basically had everyone describe why they were at Pages, what their personal goals were, what they hoped to accomplish. Get out of it. And what that did is meant everyone on the team knew why everyone else was there. And then we crafted, as a development team, a set of goals and principles that we were going to follow as a team aimed at helping every single person in our entire team to achieve her or his goals. And then and only then we said, okay, how does this fit into the company? It's sort of subversive because we're kind of like, yeah, it's team first. This is what we're interested in. But it bought in. We had basically zero voluntary turnover in 5 years. Zero voluntary turnover. And it wasn't because these weren't great engineers, they all were. But they all were bought in. They knew why they were there, they knew why everyone else was there, and we were all working for each other. And a few of us, myself and Jim Hammerly, who's the VP of Engineering, were pretty much the buffer between the CEO and CFO and all the engineers. And we were their advocates as well. I've already told lots of stories about that, and you'll hear more. So, like I said, upper management tends to see engineers as interchangeable and often somewhat childlike. Because, truth be known, we're goofy, because we're under a lot of stress, we're working long hours. You know, my kids, during the time at Pages, my kids love to come to Pages because they'd wander through the engineer's office and see all the various toys that everyone had. I still have an animatronic, well this is from Pages, I actually bought this about 10, 15 years ago. My home office, I have an animatronic chimp head, which my grandchildren were all terrified of when they were younger. Now they're mostly amused. It sounds sensitive. It sits there and shrieks and opens its eyes and opens its mouth and so on. But that's what you do to relieve stress. You know, Nerf weapons, toys. offsites. Anyway, but I think I've already told this story. We're trying to come up with carrot and stick stuff for these engineers who are all working 70 hours a week. And one of our software engineers came up to me and she said, don't they realize you're dealing with grown-ups? We're already working our butts off. You know, it's not like, well, you know, if you ship by such and such a date, we'll give you all bonuses. It's like, we all wanted to ship 6 months ago. We're not sitting on our hands, we're not goofing off, we're working as fast and hard as we can. Similarly, there was a group of 4 engineers who used to take like 2-hour lunches. And the CFO came up to me one day and said, hey, these 4 guys, they're always gone for 2 hours at lunch. And I said, John, they work 10 to 12 hours a day. I could care less if they take 2-hour lunches. In fact, I think it's good for them. And I said, I can guarantee you that at least 50% of that time is spent talking over their respective problems and swapping information. And he never bothered me about it again. Any observations on individual and team goals that any of you have faced in places you worked? Yes?
Just a quick question. You refer to like working 10 to 12 hours a day a lot as a programmer. Do you think that's like what most of us are going to end up doing? Should I be afraid?
Hopefully not. And when we get into some of the chapters in peopleware, one of the biggest endemic problems in the IT industry, and it goes all the way back, really, to the Macintosh, the Apple Macintosh. Back when the Macintosh was still in development, this is like 1983, the rumors came out, because they were working, that all the Macintosh team had t-shirts that said working 90 hours a week and loving it. And that suddenly became the gold standard in Silicon Valley. If you weren't working 80 to 90 hours a week, then you weren't a real startup, you weren't doing this. The problem is that it's hard to get more than about 40 hours of effective work, effective technical work, out of a software engineer a week on a sustained basis. And what happens when you start asking for longer hours is the time starts filling up with checking email, having meetings, staring at the wall. And I say that. I have done 100-hour stretches. I've literally done 100-hour stretches where I've worked 40 hours, or 100-hour weeks where I've worked 40 hours at a stretch. That's not sustainable. The first time I went through that, by the time we shipped the version 2.0 that I was working on, I quit and I did not program again for money for 4 years. I was so burned out. No, I'm serious. I was getting offers and I could not, the thought of going back to programming was absolutely terrifying. I was burned out. The great blessing was that I had developed on the side a writing career, and I basically started doing more writing for Byte and Mac roles, taught here at BYU, and finally got back into it. But the problem is you can burn people out. You really can. So if it's a wise company, no, you won't be working 60 to 80 hours a week. But you will find that the heroic model of software development is still very popular, not just in Silicon Valley, but throughout industry. And it usually represents a lack of understanding and vision on the part of the upper management. Yes?
Do you think that hero mentality is reinforced by like how the CS educational curriculum works? Because I feel like I spend a lot of time like trying to get really hard head on where I work, but there I work very
That's actually a very good question. I don't know enough to be able to judge that. What I do know from my own experience from the 70s, 45 years ago, back then it was all timeshare on IBM 360 or Deck System 10. And for each class you got a budget, like $100 of computer time for that class. And if you ran through that, if you ran out during the semester, you had to go back to your teacher and explain why you managed to use all that time on your handful of programming assignments. The answer was usually digital playing Star Trek or Adventure or something on the Deck System 10. But what happened a year or two in my program was that the Deck System 10 was run out of what was then the Richards building, the engineering building. And they realized the computer was underutilized at night. So they offered a discount rate. There was like a 30% discount from 6 p.m. to midnight, and from midnight to 6 a.m., there was a 90% discount. Every single computer science student started programming between midnight and 6 a.m. because you could get all your programming assignments done and still have lots and lots of time to play Star Trek or Adventure. And the interesting thing was that was actually great preparation for me. I still, to this day, I can't get to bed before 11. 45 years later. If I go to bed before 11, I'll wake up at like 3 a.m. So it's the long and short of it is you'll probably encounter it in a good organization. You won't. Yes.
From a management perspective, how do you help software engineers burn out? You give them a break?
Oh man, yeah. In my case, I quit. I quit a week after we shipped 2.0 of Sundog. And like I said, I had other game companies that were coming after me, wanted to hire me, and I started to do that, and I had almost a panic attack. It's like, I can't do this. I've been through this. I can't do this again. And I wish I had a good answer for you as to how to deal with burnout, but sometimes it just takes time and space, and sometimes change of career for a while. So the interesting thing is I worked very long, actually worked longer hours over a longer period at Pages and didn't burn out. And I think the difference there was that I was the one leading the team, at least from an architectural and technical point of view. And I felt like I had both, well, I did. I actually had more influence and more power at Pages than I had at FTL Games. And that's probably what kept me from burning out. Remember Conway's Law. I can't remember if I already mentioned this. I was brought in to review a project, a large financial corporation. It was supposed to take 2 years and cost $180 million. When they brought me in to review it, it had been going on for 4 years. They spent $500 million and they had 0 code in production. Stop and think about that. $500 million, 4 years, 2 major consulting firms, and 0 running code. I led a team for 3 months doing the review, and the first thing I said is, who's the chief architect? Guess what? There was none. There was also no head of QA. Those were my first 2 questions. So I thought, this is going to be so ugly, and it was. So I tried to figure out the architecture, and this is what kept coming to mind. This is pretty much what the architecture looked like. The whole program was spread out across different divisions with different levels within each division. There was 0 conceptual unity. It was a bunch of little fiefdoms, all building their own little things that just couldn't talk to each other. So Conway's Law, you may recall from your reading in Mythical Man-Month, Fred Brooks coined this after someone he knew, which is that any organization that defines a system will produce a design whose structure is a copy of the organization's communication structure. So if you all go back and look at your org charts that you have, that's what you're going to build. That's, on a broad level, is what your project architecture is going to look like. In many cases, it's exactly what it should look like. I mean, you've got, here's front end, here's back end, here's communication, here's database. That's good. If your org chart does not look like the overall architecture structure of the system you want to build, you may want to consider revamping your org chart. Because it tends to follow communication. Architecture follows communication. Any comments, questions, observations on this? Negotiations and love songs. This is a little piece I wrote that I really need to get back to, because this is so critical and it's so overlooked in organizations. I tend to look at this from the outside as a consultant. There are 3 different groups within a given organization, and they all have different priorities and sometimes completely different understandings. You have the people who are actually in the organization working in IT. You have the management, which is focused on business, profit, quarterly results, and so on. And then you have the end users. I have had 2 different failed project cases an expert witness, where in both those cases, a major issue was that the end users kept saying, we want the new system to work just like the old system, but better. That's not possible. If it's better, it's not working just like the old system. But people hate change. You'll hear me say that many times over the course of the semester. People hate change. We've already talked about this. How many of you, when your Apple or your particular version of Android gets pushed out and they change something? Why do they do that? The old version worked just fine. And you're trying to figure out what they changed and why they changed it. People hate change. They have an investment in understanding how things work currently, and they don't want it to work in a new way. I was using Windows 2003 up until about 5 years ago, because I hated the ribbon interface. Frankly, I still hate the ribbon interface, but I finally gave in and said, oh well. Mostly because I was experiencing more and more incompatibilities. Like people not being able to open up Windows 2003 documents. But this is a challenge you're going to have, that the end users want one thing, engineering says this is what would work, this is what we can accomplish, and management says, hey, we just promised these 3 features to our customer base. This is a constant challenge. So read the article. Any questions or observations on this before we move on? Let's go ahead and take the break now. Come back at 10 till. Take a biology break now. Come back at 10 till. We'll take roll.